Section 1.1 is variables and expressions. I can write algebraic expressions. Big ideas for this section. Algebra uses symbols to represent quantities that are unknown or that vary. Mathematical phrases and real-world relationships can be represented using symbols and operations. A mathematical quantity is anything that can be measured or counted. Some quantities remain unchanged and are called constants. They're constantly the same value. 6, for example. If I say I have 6 apples, you know exactly what 6 means. If I say I have something that varies, those are called variable quantities. So if I say the amount of apples I have varies, I have X apples at any given time, that's not super helpful to see in your head exactly how many we have. But sometimes that is helpful when it comes to solving problems or trying to figure out how many we need to get to a certain number, for example. A variable is a symbol, usually a letter, that represents the value or values of a variable quantity. It doesn't have to be a letter. We just use letters because those are things we're already familiar with, already draw fairly quickly. We could make them smiley faces instead if we wanted. We just use the letters because those are already part of our day-to-day. An algebraic expression is a mathematical phrase that includes one or more variables. So as long as it's got variables in it, it's algebraic. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. So if all it is numbers and like pluses and minuses and things like that, it's numerical. If it has any variables at all, it's algebraic. Example 1 is writing expressions with addition and subtraction. What is an algebraic expression for the word phrase? 32 more than a number. So we're going to start here with a number n. And we're going to take 32 more than that. Just like if I say I have $5 more than I had yesterday. So I take however much money was in my pocket yesterday and I add 5 to it. Same idea here. So we're going to start with a number n. And then 32 more than means we add 32. 58 less a number n. So it's not less than. Anytime we have than, that's when we're comparing two things and we want to switch our order. But here's just 58 less a number n. So here we start off with 58. Less is another word for subtraction. And our number here is n, our variable. C is 58 less than a number n. We have this than there, so we're comparing two things. We started at n. And now we have less than, which means minus. So minus 58. 58 less than a number n. So if I used to have 100 and I have 58 less than that, it's like I subtracted the 58 to find my new total. Now feel free to pause here and give these a try if you'd like. What is an algebraic expression for 18 more than a number n? Well, it's more, which means add, and more than, which means we're comparing. So we're going to start off with n. And we're going to add, because it's more than 18. So 18 more than a number n means we started somewhere, and then we added 18 more to it. So n plus 18. When you add, the order doesn't really matter because 2 plus 3 is the same as 3 plus 2. But when you subtract, it does. So it's a good habit to get into that anytime we see that than, we make sure we have it in the right order. Example 2 here is writing expressions with multiplication and division. We want to find an algebraic expression for the word phrase. 8 times a number n. Times means multiplication. So I'm going to take 8 times a number n. And we can write that a couple different ways. We could say 8 times n, we could do 8 times n, or anytime we have a number and a variable right beside each other, that means multiplication as well. So 8 times a number n. Quotient means we're going to divide. And when we do that, the quotient of a number n is where we start in our numerator, and 5. Okay, so when we have quotients, we write them the same way that we read them. So since we read n and 5, we start at the top and go n over 5. We also could write this as n divided by 5 if you wanted, or as a fraction, doesn't matter. Big thing here is quotient means division, and to get them in the right order there. Now, feel free to pause here and give this a try. What is an algebraic expression for each of the following? 6 times a number n times means multiplication. So here I'm going to take 6 times a number n. And again, you can do 6n or 6 times n. All of those mean the same thing. The quotient means division of 18 and a number n. So we start at the top, 18 and a number n, or we can do 18 and a number n. And it's quotient, which means we're dividing. So either of those work, and same on top, any of those work. Example 3 is writing expressions with 2 operations. So here we have an algebraic expression for the word phrase. 3 more than. So here, this 3 more than, we know means since it's got that than we're comparing, we're going to end up adding 3 to something. And we're going to take that and add it to twice. Twice means 2 times a number x. So since it's 3 more than twice, that means we're going to do that twice part first. So we have to take 2 times n first and then add the 3. 9 less than the quotient of 6 and a number x. So with these, a lot of times, guys, it's helpful to read through them first. So here we're going to go 9 less than, which we know since it's got that than we're comparing, and we're going to end up subtracting 9. Quotient means division. So we're going to take 6 divided by x. So 6 divided by x, and then we're going to take 9 less than that. 9 less than the quotient. So we have to do our quotient first and then subtract 9. We could also write this as 6 divided by x minus 9 if we wanted. See, here's the product of 4 and the sum of the numbers x and 7. So product means we're multiplying, so we're going to multiply 4 times the sum. Sum means we're going to add. So 4 times the sum of x and 7. So x and 7, okay, is our sum. And since we need to do that sum first, I'm going to put it in parentheses. So 4 parentheses x plus 7. The product of 4 and the sum in parentheses of x plus 7. And we have to do that first, and the sum goes in parentheses. We could have put it in parentheses before when we had division as well, but their order of operations, which we're going to get to in a little bit, said we didn't have to. But here, anytime that we're multiplying a sum, that sum has got to be in parentheses. We could have put the 4 at the end here. If we wanted, we just usually put our number part first. Feel free to pause here and give this a try if you'd like. What is an algebraic expression for each of the following word phrases? 8 less than the product of a number x and 4. So 8 less than means we're going to subtract 8. It's got that than that compares, which means it goes at the end. And we're going to do that from the product, and product means multiplication. So we're going to take x times a number 4. And I'm going to rewrite that so my number part is first as 4x. And remember, that's our product part, and it's 8 less than the product. Product is multiplication. So our product goes first, 4x minus 8. Twice the sum of a number x and 8. So here we have twice, which means 2 times the sum. And anytime we're multiplying with a sum, that sum has got to go in parentheses, and that's a number x and 8. So here it's 2 times x plus 8. And again, just like we did before, the 2 could go at the end. You could have your multiplication symbol. A lot of options there. Here we have the quotient of 5 and the sum of 12 and a number x. Quotient means we're going to divide, and we're going to divide 5 and the sum. So 5 goes on top, the sum goes on the bottom, and that sum is of 12 and x. Sum means we add. Here's one way we could write it. We could also go 5 divided by, and again, the sum here means we're going to have to put parentheses, 12 and x. And as long as we write it as a fraction, the only thing on the bottom is that addition, so we don't need the parentheses. But if that denominator would have had something else with it, then we would have had to. Just like here, we have 5 divided by the sum, so it has to be in parentheses. Same thing would have had to happen here. It's just in our denominator, the only thing we have is that sum. What word phrase can we use to represent the algebraic expression 3x? First thing we need to do is figure out what our operation is. And anytime we have a number and a variable together, it means that we are multiplying. So here, I can say this is just 3 times a number x. And when we have our variable, we want to say a number x instead of just 3 times x. Or another word for multiplication besides times is product. So we could say the product of 3 and a number x. Okay, either one of those works. So the big thing here is make sure you pick out your operation and then come up with a word for that. So times or product both mean multiplication. And then write out your statement. So we've got a couple options here for some of these. So what word phrase can be used to represent the following algebraic expressions? Here we are adding. And the word for that I'm going to use is sum. So I'm going to say the sum of a number x. And we put that on number x just to remind people that, hey, this represents a quantity. And 8.1. Okay. The second one here, we have 2 operations. We have adding and we have multiplication. So multiplication can be times or product. And adding can be plus or sum. So here, I'm going to do the sum of 10 times a number x and 9. We also could have done the sum of the product of 10 times the number x and 9. That gets a lot of ofs in there. We could have said 10 times a number x plus 9. But I'd like you to use at least product or sum for that to get just a little bit more of those math words in there for you. Here, our operation, anytime we have a fraction, that just means division. It's like our top number divided by our bottom number. It makes a division sign. So the word we use for division is usually quotient. So here it's the quotient of a number n and 3. And remember, we go top down just like when we read. We start at the top of the page and work our way down. Same thing when we read a fraction. So it's n divided by 3, the quotient of a number n and 3. And here we have 2 operations again. We have a subtraction sign and we have multiplication. So for multiplication, again, we can use times or product. And for subtraction, we can either use minus, less, less than, some options there. So I'm going to do, since I used product before, I'm going to just use times. So 5 times a number x. And I'm subtracting 1 here, so I'm going to say less because I take that away. 1. We could say 1 less than 5 times a number x. We also could have said 5 times the number x minus 1, the product of 5 and x less 1, or 1 less than the product of 5 and the number x. Lots of options there. Okay. And I'm going to stop this video here, and I'll continue on in a new one.